Alright, Mr. Claxon's algebra students, if you watched the previous video, we identified what we're doing today, solving those radical equations, and we're going to use the same recipe we used earlier on in the week, but now we have some extraneous solutions with our radical equations that we're solving, which make me want to pull, well, the hair that I have left out, because you think you did something right, and then you plug it back in and it doesn't work out. And I went through this example with you of why this doesn't work out. We chose to substitute our solution back in. We did the check step here to find that, whoa, that's an extraneous solution. See, typically I would think I did something wrong here, but no, extraneous solutions are possible. If you didn't, let's say that you didn't trust yourself there and you wanted to get another visual, you could graph both of the left side and the right side. You could graph it. You would need to, you could use your graphing calculator for that. Maybe set y1 equal to the square root of x minus 12 and y2 equal to 2 minus the square root of x. You'll see that these never intersect. One's going up and to the right, and the other's going down into the right. So they're never going to cross paths. They'll never be equal to each other. The left side will never equal the right side. And so that's why we're going to have no solution effectively. Here's another example that I did, and I just went ahead and did the example here. I'll kind of explain it real quick. The first thing you should notice is, hey, we've got two square roots here. So we're going to go ahead and square each side to get rid of one. When we square this binomial, it's going to create another square root for us. You can see my work for that, the FOIL, or the distributive property, twice over, right up here. So what do we have to do? Now we've got to isolate this square root. Subtract x from each side. Really, I could have just crossed the x's off. And what do we get? Well, we have to subtract 25, then divide by 10 on each side. We get the square root of x is equal to -1. Well, you should be saying to yourself, in the real numbers, that's not possible. This should, this should sound alarms in your brain. Or maybe you're just going to pause and think, wait a second here. If we're working with the real numbers, this isn't possible. So that's why we're going to end up getting no real solutions for this problem. We're going to call that x equals 1 an extraneous solution. And, our final answer there of no solution is really because the left side will never intersect with the right side. We've got the left side, that's the red there, it will never intersect with the black. And if you understand rates of change, this is what it would look like if you dusted off that graphing calculator and plugged it into there and then put this window in. These are never going to cross. Because they never cross paths, that's why we would call it a no solution. I want to go back, though, to that example 1b here. I'm just calling this example 1d. It's really example 1b in the book. I want to explain where this 4 minus 4 square root x plus x comes from. So if you know that already, you're good to go. I'm just going to show you another option here. You can do some side work. That's work done off to the side to FOIL that. So 2 times 2, you get 4. And then you got your outsides. 2 times negative square root x is negative 2 square root x. Negative square root x times 2, negative 2 square root x. And then we've got this negative square root x times the negative square root x. Well, I know that a negative times a negative is a positive. And then we've got square root x times the square root of x. Well, that's going to end up being the square root of x squared, which is just x. The square root of x squared is x. That's right. And we combine these two middle terms here. That square root of x, that's like a like term. So we see that that's like a like term. We combine like terms to get minus 4 square root x. That's how we get the right side here. Now there's another way you could do that. If you're familiar with how a multiplication chart works, you can write 2 minus square root x. Notice how I just kind of put the minus off to the right there. And then we write 2 minus square root x. Notice how I put the minus with the square root x. And then we just multiply. 2 times 2 would give us 4. 2 times negative square root x, negative 2 square root x. And then 2 times negative square root x, negative 2 square root x. And then negative square root x times negative square root x. Negative times negative is positive. Square root x times square root x is just x. That's just another way. You're going to see that in a couple examples. Now I'm just going to start. Skipping through this. We've already learned the other stuff earlier in the week. I want to focus on these extraneous solutions right now. So I'm just going to go ahead and jump down here in your homework. You did have to do number 3, or maybe you haven't done the practice problems yet. Subtract 8 on each side, divide by negative 1 on each side. And that's kind of a confusing step. Students forget to divide by negative 1, so I just wanted to highlight it for you there. You didn't have to do 9, but with number 10, students get confused on this one because they think the 4 is raised to the 1/2 power. No, it's only the z. Only the z is raised to the 1/2 power there. So subtract 2 from each side, divide by 4 on each side, and then this should sound alarm bells in your head. The square root of a number is equal to a negative? Ah, not so fast. I think we're going to get an extraneous solution here, and we do. Our final answer would be no solution. No solution. Moving forward there, that is not your assignment for tonight. That's just another way of doing number 10. If you do want to see a problem that's similar to what I did at the beginning of this video, maybe you could pause it now. You could try to do number 25 on your own. Probably don't want to do that because you had 27 as a homework problem. So this is the answer to that if you want to try number 27 there. And then show you what that window would look like so you could see maybe both of those graphs if you decided to do that for the check step. And then you had 28. Number 28 was a homework problem. It was a practice problem. I do it for you here. I don't really feel like I need to explain it. Hoping that you're going to be able to finish that on your own. Maybe if you need help, you can refer back to it. For 53, with 53, when we isolate this radical inequality, we isolate the radical. And I know some of you might have been saying, wait, don't we have to figure out what values we can plug in? Yeah, you could have done that first. But is this even possible? Can we have a square root less than 0? Well, what does less than 0 mean? Well, it means negative. Not possible. And then down here, so when you isolate those radicals in the equations above, like which one are we looking at here? Which one's going to give us a square root equal to a negative? And that's going to be our answer. So hopefully this helped you out. I know it was a little longer than I wanted it to be, but I hope that you maybe have just a little more information to go off of and less frustration. So enjoy doing that math homework. Enjoy the logic and reason of mathematics. Let's go.